I gotta throw things around, but it's okay. Okay. Oh, shut up, phone. Thought I muted you. Apparently not. Okay. So you get 2xy plus 5 and then 2x plus 5y equals 1. So a couple options at this point. Either way, you're going to substitute things in and solve. You want to try to get rid of a variable, obviously, so to get it into another variable. So what a lot of people probably would try to do is like substitute this equation into over here. So the 2xy plus 5 into the y. That wouldn't do you any good. You'd still be doing two variables. So you have one of two options. You could solve this left-hand equation for y. So in other words, you have to get y by itself, because right now it's not solved for y. It'd be much easier on the left-hand or the right-hand side to solve this one for x and substitute in my opinion, though. Either way, you're going to be dealing with fractions. It's not going to be the prettiest thing in the world, but so I would solve this one and then divide by 2. So x is equal to 1 minus 5. Oh, the fraction actually goes away. That's pretty nice. And then take that, put it in there. So y is equal to 2, 1 minus 5y over 2, y plus 5. So y is equal to 1 minus 5y times y plus 5. Y is equal to y minus 5y squared plus 5. So actually the y's go away, so it's not too bad. So you get 5y squared equals 5. So y squared equals 1. So y is equal to plus or minus 1. Any questions on what I did there? Okay, then what would my next step be then?
Where did you leave off at?
I just solve for y.
Plug both points back into one of the equations to get x.
Yep. And specifically, I would plug it into the one that you've already solved for x. So even if you did this the other way and solve for y, you'd still have this explicit equation over here for x. So I'm going to take these and plug them in there. So you get x is equal to 1 minus 5 times 1 over 2, and then comma 1 minus 5 times negative 1 over 2. So you get negative 4 divided by 2 is negative 2, and 6 divided by 2 is 3. This is where you do have to be careful, because you're not just looking for these points and things like that, you're looking for their midpoints, so you got to put them together appropriately. So the coordinates here would be negative 2 comma 1, and was it 3 comma negative 1. And then you're looking for the midpoint of that. So you do midpoint formula, you add them together, divide by 2. 1 plus negative 1 over 2. So you get what? 1/2 comma 0. And there's your answer.
Yeah.
Does that make sense, hopefully?
Yes.
Yes.
Any questions on what I did? How I did? Okay, moving on to number 2. Okay, so obviously we're using some way of, most people would think we're using a way of completing the square. So there's a couple of different options you can do for this problem. Typically when we talk about completing the square, you would say to yourself, oh, it's got to be in the form of just x squared to complete the square. And while technically that is true, you can kind of do some fancy things to get there. I'll show you what I mean by that in a second. But I also showed you guys a technique that's a little easier than that, in my opinion. So notice how does the problem say use complete the square or anything like that? Does it give you any sort of directions?
In the form 3x minus a squared minus b.
But other than that, to tell you how you have to do it or anything like that, as long as you can get there, do they care how you get there?
Oh, no.
So that's important to note. Sometimes they tell you, use completing the square, use this method, do this, and you have to use that method. Here they didn't tell you anything. So this is where when I talked about this type problem before, was it plus b, minus b, I don't remember. Minus b in this case. So if they give you this form, and they give you, minus b, it was what, 9x squared minus 15x. So we want to get this to that form. Well, what we want to figure out, we can also do, remember I talked about, you can multiply and distribute this out and get yourself 9x squared minus 6xa, or actually 6ax would probably be better, plus a squared minus b. At that point, hopefully, one of the variables to find should be really easy. You should realize that a is extremely easy to find because a and this has to match up. So you get that negative 15x equals negative 6ax, which means negative 15 equals negative 6a. A is equal to what, 5 halves? If I did that right? Yeah. At which point, how do I find b now? Anybody have any suggestions?
Don't you have to like plug A in and then it's gonna be whatever would make it cancel out?
Possibly, but that's not enough direction, unfortunately. Because I don't know what you mean cancel out. What am I canceling out? You gotta be more specific.
Like whenever you put into the 3x minus a, that whole thing squared thing, there's no so it's just the 9x squared minus 15x.
Okay, sort of, but you're on a difficult path at that point. What you should realize, or the intent of what you should realize here, is that a squared minus b equals 0. So you went too far back up. So I don't have a number over here, so it's got to be, this has to be 0. I know what a is, so I get 5 halves squared minus b equals 0. So b is 25 fourths. So then you get that 9x squared minus 15x is equal to 3x minus 5 halves squared. Oops, yeah, no, that's right. 24 fourths you can simplify. What, 6 halves? No, just 6. I'm just going crazy. Minus 6.
Wait, isn't it 24 over 4?
25.
I mean 25 over 4.
I was ahead of myself. I was like, wait a minute, something's not making sense here. Yeah, thank you. I was like, something's not adding up. How is that? So 25 4. Okay, does that make sense, hopefully? Any questions on what I did, how I did, why I did?
Why did you set it equal to 0?
Because a squared minus b is a number, correct? Those are both numbers, no variables.
Yeah.
What number do I have in 9x squared minus 15x?
None.
Which means I have what number?
0.
0. So this is well, I remember we talked about this. This is what's called equating coefficients. So obviously 9x squared equals 9x squared, no big deal, there's no variable there. But I know that the negative 6ax has to be equal to the negative 15x because that's the only term with an x in it. And I know the a squared minus b, which are my constant terms, has to be equal to 0 because there is no constant term in the original problem.
Oh.
Hey, that's kind of what I said.
And I said that you were just on a bad path of doing so. You were on a much more difficult path of doing that. Okay, so now for step B, giving the hint here that you have to do A in order to do B, because if you notice, 9x squared minus 15x is what you just expressed in that form. So you're going to have to use that form right there that you just found in order to solve that. So it's, what, less than 6? Yeah. So basically they're asking the question that 3x minus 5 halves squared minus 25 fourths is less than 6. So now they want you to solve this quadratic inequality. Okay, so how am I going to solve the inequality? Any ideas?
I took out, like, divided everything by 3 after moving the 6 over, and then I factored it, and yeah.
Does this one factor out nicely if you do that? I just assumed it didn't.
Yeah, it
Oh,
does.
so you may not need to use this. You could use this, I guess that's an option. So let me see. So minus 15x minus 6. You get 3x squared minus 5x minus 2 is less than 0. 3x. This would be minus 2 plus 1. Hey, this one does factor pretty easily. Okay. So you don't have to use what you just factored. You can use what you just factored. That is an option as well. That's okay. Nice. Or you could go ahead and subtract it over and factor. So this problem actually has 2 ways of doing it. This would probably be an easier way, in my opinion. I just assumed it didn't work. But it does. So the question is, and we've talked about this before, if you're using this method, how do you solve that for the correct answer? Because we did look at doing this on the fake test thing that I gave you guys that nobody passed. So how do I solve an inequality? Remember, quadratic inequalities is something you've probably, for the most part, forgotten because, well, not very many people did it correctly. So how do we solve this? Which is, we've done this before in calculus. We've had to solve things like this. So how do we solve this, guys?
I mean, I just split it into 2.
That is not a correct way to do it.
Is it a number line?
It is a number line, yes. This is just like a first derivative. If I'm trying to figure out where a first derivative is less than 0, we did a number line test. Remember, the reason you can't just take them both and set them less than 0, if they are both less than 0, then I'm multiplying them. Then you end up multiplying 2 negative numbers, and that gives you a positive number. Because you're multiplying here, this is a very different thing. There's a couple ways to do this problem, really. You should realize what this equation is. Everybody should know what this 3x squared minus 5x minus 2 is. And I'm getting no responses. What is 3x squared minus 5x minus 2? What's the equation of?
This sounds dumb, but like, wait, never mind, I don't want to say.
I mean, it's a pretty basic answer.
Parabola?
Yay, it's a parabola. So you should realize this is what kind of parabola, because it's a positive 3. What kind of parabola is this? Which way does it go?
Concave up.
That's true, but what stuff? That's not how far. I was expecting a little simpler of an answer. It just goes up. We don't care about the concavity necessarily, but it goes up. So you should know your parabola has zeros at 2 and negative 1/3 and does that. So where is this parabola less than 0? In between there. So you should know that being the answer. However, if you can't remember that, you can do a number line, with the values of 2 and negative 1/3 on there. Numbers over here will be positive, numbers here negative, numbers here positive. And since you are looking for less than 0, you're looking for numbers that are negative. So that's why the negative places the answer, so the numbers from negative 1/3 to 2. So negative 1/3 to 2. We put parentheses on them because it is not an equal to, so I don't need the place where it is equal to 0. Does that make sense? Hopefully, because, well, we've done a lot of that in calculus this year.
Yes.
Okay, number 3. Find the real roots of equation blah. Okay. 36 over x to the 4th. Plus 4 equals, what's the right hand side? 25 over x. Anybody have any ideas for the first thing I should do?
Get x on top.
Be a little more specific than get x on top. There's a lot of different ways I can do that. Okay.
Like the
Actually,
little
the
thing.
square root of everything.
How the hell did you do that?
Can't Bridget?
Make it equal to 0. Like the equation.
Okay, so I'm going to combine a couple of the steps some people said and disregard square rooting everything. So the issue of the square rooting of everything is you can't square root the left-hand side individually. You can only square root the whole thing. And the left-hand side itself is not a perfect square. So that would not be a good idea. So I'm hoping you did not do this right here.
Because, I see.
So I'm assuming you did what's on the right-hand side over here when it comes up on the screen, Bridget. Please don't ever do that.
I think I got the answer right, though.
That would be a very large coincidence, because you can only get 2 answers from what you did, where there's 4 answers in total. Okay, so at this point, we do need to get rid of our fractions. We talked about that when we did the problem in class. Multiply by your common denominator. Well, if you have to, put the 4 over 1. What's the common denominator between x to the 4th, 1, and x squared?
X squared.
Not a true statement.
What?
X to the 4th. Yeah, multiply by x to the 4th.
X to the 4th. The biggest powered one is always your common thing. So I'm going to multiply everything by
Okay.
x to the 4th, giving me 36 plus 4x to the 4th equals 25x squared. Now I'm going to take, I believe it was Kayla's advice, and get it equal to 0, because this is a quadratic equation. And I'm going to rearrange at the same time, so 4x not squared. 4x to the 4th minus 25x squared plus 36 equals 0. Now, at this point, you have a couple of options. If you don't feel comfortable factoring an x to the 4th and an x squared, you can make a u sub of u being x squared if you want to. And which I would probably suggest to most of you, because you guys aren't as comfortable factoring things. So this is u squared minus 25u plus 36. Then at that point, you had to realize that this is a factorable equation. You could also use the quadratic formula if you don't like factoring. If factoring's not your thing, you could factor this in multiple different ways. Let's see. And then that would be, that's not right, 9, no, 18, and I'm assuming it factors, I don't know.
Is it 4u minus 6 and u minus 6? Wait.
Yeah, that works. So it'll be, it's 4 and 1 is the thing. So 4u, I need a minus 6 and a minus 1. That works. I was getting there eventually. That's probably one of the last options I would have. No, it would have been. That's not right. 6 and 6. So yeah, that's not right.
See that?
Isn't it 4u minus 9 and then u minus 4?
So you said 4u minus 9 and u minus 4. Negative 16, negative 9. That is correct, yes. Good job. So however you factor, go through it. You can do that. Remember, if you need to, I showed you guys the slide and divide technique for those of you that are bad at factoring and don't like factoring. You can move the 4 over, you do the slide and divide. You can also use the quadratic if it's really stumping you. It's not a big deal. However you want to factor, however you want to solve it, doesn't matter. They don't care if you use quadratic, if you use factoring. As long as you can solve it correctly, do it. And if you need help with any of those topics, as far as like that, please come and talk to me. I can show you. I can help do one-on-one if you need to, or small group if more than one person needs it. So at that point, we just solve these. So 4u equals 9, u equals 4, u is 9/4, when u is 4. We do have to make our substitution back in, so you get x squared equals 9/4, and x squared equals 4. So x is equal to plus or minus, do not forget the plus or minus, 3/2 and 2, plus or minus 2. Yay, we got it right. Any questions on how I did anything so far on that one? Or
No, you made it very simple.
I try to. So that's my job.
I don't know why my brain can't think on my own.
I'm waiting for.
You're waiting for what?
Every time I try to watch the live, it lasts for like 5 minutes, and then it never works.
Kind of sounds like your internet's not very fast because you keep breaking up on your when you're talking. So I think your
It's also
bandwidth
because
may not be very high.
I'm actually words away from the router.
That's probably not a good idea. Something you might want to do, because the school has the hotspots, you might want to talk to somebody like Miss Palfrey or somebody about getting a hotspot. I don't know who has directions of giving them out, but the schools are. So
That would be nice.
all you gotta do is go talk to them. They send out a lot of information about this stuff.
They also have these things that you can use that you can buy to like extend how far your Wi-Fi goes. I had one at my dad's house like a couple of years ago because our house is like really large and spread out, so it like stretched for the whole house.
It's called a Wi-Fi repeater or a range extender, one of the two.
Something like that.
All right, moving on to number 4. Find the set of values of k, which means there's more than one most likely, for which the line intersects the curve at 2 distinct points. Okay, what the heck does that mean?
Yeah, I don't know.
I watched a video.
Okay, what does it mean that it intersects it at 2 distinct points?
They said the discriminant is greater than 0.
That is a false statement as of right now. So
Dang, getting it on.
she's jumping steps and not understanding what they said apparently, or just not remembering everything they said. So the thing about it is, if they intersect at 2 points, that means the system of equations has 2 answers. So you're going to solve this lovely system of equations. Y equals x squared minus 9x. And y equals, what was the other one? Kx minus 3. So this is a system of equations. Obviously one is a parabola, hopefully you can see that, and one is a line. In order for it to intersect at 2 points, when I solve this system of equations, I need to have 2 answers. Now that might, and a good use of it will be involving the quadratic, possibly. But basically, easy way to do it here is you can set these two equal to each other. And then, since you have a quadratic equation, you are going to set it equal to 0, so minus 9x minus kx plus 3 equals 0. I would personally go ahead and factor this as 9, and I factor out the x. So x 9 plus k plus 3 equals 0. Something along those lines. And then yes, now at this point, probably the easiest way would be to realize that in order for a quadratic to have two real solutions or two solutions, that the quadratic, the discriminant has to be greater than 0. So we can't forget that with our quadratic equations. We have three options. Greater than 0 is less than 0. So you have the discriminant, which is the piece inside the square root from the quadratic formula, if you can't remember, or the quadratic equation. And then it's equal 0, greater than 0, or less than 0. Those are the only options. What happens if your discriminant is equal to 0?
You have one solution.
One real solution.
What happens if it's greater than 0?
Two real solutions.
Okay, the real part is important. And what happens if it's less b squared minus 4ac, which left off to c, is less than 0?
No real solutions.
That's not enough information. Be more specific than no real solutions. We're not in algebra 2 anymore, or algebra 1. We're now in calculus. What does it mean if you have b squared minus 4ac is less than 0?
Like undefined?
Nope.
Imaginary.
Be more specific, Deborah.
One
The
imaginary
answer
solution?
is
I don't know.
imaginary.
Be more specific, and no, Thomas, that is not correct.
Are you trying to say non-real?
No,
Was it only one imaginary?
that is not correct, Mr. Anand.
I don't even know what a discriminant is.
I told you. I literally just went over this, Bridget. It's the part
I
underneath the
literally had
quadratic.
Bad internet, and I had to leave Discord on my computer and pull it up on my phone because my computer just like pooped itself. It's not
Oh.
working.
Well, you sound better on your phone. But the discriminant's the part underneath the square root in the quadratic.
Oh.
Remember b squared minus 4ac under the radical? So what happens if you have a negative answer underneath the radical? Clearly we have what kind of numbers?
Fake.
Negative.
Wait, what was it? Whenever it's less than 0?
Imaginary.
Yeah, thank you,
We
Anand.
said that.
Yes, I was reiterating that, but I got the answer of fake, and then something. Then I got an answer of negative. So yes, so reiterating. If you have b squared minus 4ac, which is underneath the radical, is negative, aka less than 0, you get what kind of numbers? The answer is
Imaginary.
imaginary. How many imaginary?
Infinite.
Two.
One.
So I've got an answer of 1, 2, and infinite. You get 2 imaginary roots.
Okay.
Remember,
Uh-huh.
it is
Oh,
plus or minus the square root of b squared minus 4ac. So I get one positive version and one negative version. The reason the top one is you get one real solution because plus the square root of 0 and minus the square root of 0 are the same thing. So that just disappears. This one you get plus or minus a real number, and this one you get plus or minus an imaginary number. So that's why you get one real solution, 2 real solutions, 2 imaginary solutions. We can't forget that. So at that point, we just use the quadratic and solve. So.
Are you on number 4?
Oh.
Yes.
Yes.
Okay, I'm gonna be honest. I don't know how any of that applies. I was just like, okay, well, derivatives are gonna be equal because.
No. It's not true.
I literally got the exact right answers. Look, okay, I took the derivatives on both of them. I was like, okay, y prime equals y prime, k equals 2x minus 9. I plugged k in. I got the exact thing though.
No. You should not have gotten the right answer.
Okay, are we doing question number 4?
Yeah, the derivative has no impact on this question at all.
I promise. I got okay, never mind.
Okay, we'll see if you get the same answer I did in a second. So using the discriminant now, I only have to do the b squared, so I get 9 plus k, because that is my b value, the value that's attached to x, and it would be negative out in front of it. So So negative 9 plus k squared minus 4 times 1 times 3. And we need that to be less than 0. Or sorry, greater than 0. So I went 2. So then at that point we solve, so we get another quadratic equation, which is a pain in the butt, but it is what it is. So the squared makes the negative go away, so we get k squared plus 18k plus 81 minus 12 greater than 0 plus 18k. 81 minus 12 is 69. Greater than 0. Is that a factor? I need a calculator because I don't know if that factors or not on top of my head. Are you serious? It doesn't factor? Jesus.
No.
Oh yeah, it doesn't.
It's got square roots in the answer, so you, God. Okay, so at that point you choose the quadratic again. The actual full quadratic this time. So negative 18 plus or minus root of 18 squared minus 4 times 69 over 2. So k equals that. Calculator, because I don't know what those numbers are. And so while I'm pulling this up, Miss Bridget, what did you get for your answer? Bridget. Oh, she's muted herself. Okay. Alright. So 18 squared minus 4 times 48. Okay. So you get negative 18 plus or minus root 48 over 2. Simplify your radical, which everybody should be able to do. So 48 is divisible by, what, 16? Right? 16 times 3?
Yeah.
Yeah. So negative 18 plus or minus 4 root 3 over 2, which is negative 9 plus or minus 2 root 3. So what does that mean? Are those my answers for k?
Wait, can you say that again?
I asked if those were my answers for k.
The something minus root 3 blah blah blah.
The negative
Yeah.
9 plus or minus 2 root 3.
We can't see it in the board.
I mean, that's what it says on the answer key for Cambridge, so. Like, they have those.
I know this.
Okay. Well,
But
I mean, it
that
feels
is
like
not the
you're
answer.
tricking us.
Because that's not the answer. You're not done. Oh,
When
the
we
calculator got
have to
pulled
plug
up.
it back in.
My bad.
Because the signs.
Thank you, Deborah. I didn't realize that you meant the calculator was up. I was moving my phone around so I didn't think you could see. I didn't realize it automatically pulled the calculator up when I pulled it up that time. No, the reason is because those values for k are where the function is equal to 0. Do I want where the function is equal to 0? I want it greater. You need to do a number line, just like we did last time to solve an inequality.
The signs.
That has no.
Okay, never mind.
2 squared is 3, and then negative 9 plus 2 squared is 3. I don't care where really they're at. Obviously, you would need a calculator to figure out exactly where that is. So 2, let's see, square root of 3, so that's like negative 11, 12-ish. And then the other one's like negative 7 or so. So just check your values in between and outside. What you end up finding out is that just like a parabola should be, it's negative, positive, positive.
Mr.
We
Donald,
want where it's greater than 0. Yes, Kenna?
I kind of have to go because I have a meeting with Ms. Messer.
Okay,
Alright, bye.
bye. So you want where it is greater than 0. So you're going to solve, it's both of those. So where k is greater than -9 plus 2 root 3, or k is less than -9 minus 2 root 3. So relatively long problem, nothing about it hard. You're just using the quadratic kind of multiple times, which sucks, but nothing about that should have been undoable.
Okay, wait, Mr. Donald.
Yes, Bridget.
I don't like. I literally got those numbers. I just forgot to plug it into a number line, but like it would have been right. So why can't I like do that?
There's no way using derivatives you got those numbers.
I literally did. I'm not lying. Unless I'm just wrote
Sweet.
that down and didn't use it.
I just took the derivative. The derivative is 2x minus 9 and k. Those no way in shape any form get you -9 minus 2 root 3 or -9 plus 2 root 3.
Can I just tell you what I did?
You can send me a picture if you want to, and I'll look at it, but
Okay.
the derivatives have nothing to do with this at all.
Okay.
Okay, and number 5. Find the set of values k for which line meets the curve. Oh, is that the one you just did? Or is that... I know there's 2 k's in this case. So this one's the same thing. It's going to be another lovely quadratic. Great. Hopefully it's a little easier. Hey, these come out to be real numbers, or like normal numbers this time, so it should not be nearly as hard. But yes, on key important note here, don't forget your discriminant. Anytime you're solving quadratic equations and you want 2 distinct real answers, you want 1 answer, you want imaginary answers. When they start telling you that kind of stuff, that's your clue to a discriminant with a quadratic equation. 5, 2x plus k. Second one, 2kx. Okay, so at this point, again, we want them to meet twice. So what are we going to do again? Somebody, anybody?
Set them equal to each other.
Careful when you say that. You're going to set the right-hand sides equal to each other. So you get... So this is almost identical to the problem we just did, to be honest. Get x squared, I'm going to make it positive, so I'm going to move everything over here. So x squared plus 2x minus 2kx plus k minus 1 equals 0. Yeah, we're going to factor. God, why is it, these are a pain in the butt. I hate doing these sometimes. So I'm going to factor out, it's going to be 2 minus 2k x plus, I'm going to do something here that you guys may not think to do. I'm going to put my k minus 1 in a set of parentheses. The reason I'm doing that is to let me know that that is one value. That is our c value, actually. So now the reason for doing that, our a value is 1, b is 2 minus 2k, and then c is k minus 1. And they want this to what, meet twice? Again, right? Yeah, so if it's meeting at 2 distinct points, use the discriminant and set it equal to or greater than 0. So b squared is 2 minus 2k squared minus 4 times 1 times k minus 1. So that greater than 0. It's literally an identical problem to one we just did. Just different numbers. So 4 minus 8k plus 4k squared minus 4k plus 4 greater than 0. So you get 4k squared minus 12k plus 8 greater than 0. In this case, you can divide by 4 nicely. So k squared minus 3k plus 2 greater than 0. K minus 2, k plus 1. This is the one they should have given to you first. God. I don't know why they would reverse that. Why they wouldn't reverse that order. But whatever. So then at that point you do your number line with -1, 2, and you get plus, minus, plus. So k is less than -1, or k is greater than 2. They really should reverse the order of those questions. That's dumb. And I like how this one's worth 5 points. The last one's only worth 4 points. Wonder if there was an easier way to do the last one now. But I don't think so. So hopefully that should make sense after we did the last question already. This one's actually a lot easier. Any questions on that one? Okay. Number 6. Who used calculus to do number 6?
Me.
Did they show it to you in a video, Kayla?
No.
So you have two options for number 6, or for 6A specifically. The easiest and by far way I would do this is by using calculus, since we're in calculus. You can do this using algebra 2 if you really want to and find the vertex. There's a formula for it and everything, but calculus is by far the easiest way to find the vertex of a parabola. What do we know about the vertex of a parabola? Not Kayla, since you've already done this. Somebody, anybody, how do we find the vertex of a parabola using calculus, besides Kayla? Guys, what do you know about a parabola's vertex using calculus? Think about all the things we've done in calculus. What do we know about the...
Oh, there's a vertical, there's a tangent line there.
There's a horizontal tangent line. Yes, thank you, Thomas, on it, and we go. Horizontal tangent line. So by far the easiest way to do this is to take the derivative, which is 8x minus 12, set it equal to 0, and you get what, 3/2. Do they want the actual coordinate, or what do they ask for? Find the coordinates of the vertex. So we need the y value. So just plug your 3/2 back in up here. Remember, you do get a graphing calculator, or a scientific calculator, not graphing. So it can do that for you as well. So you get 36. So y of 3/2 is 36 over 4 minus 36 over 2 plus 7. 9 minus 18 plus 7. That's what? 16, so -2. So 3/2, -2. And done. So, make sure I get that right. I did, okay. So, by far the easiest way to do that. If you want to do the algebra way, you can use the x equals -b over 2a thing. You get a relatively similar answer. It's easy. The problem is it's just extra to memorize. So I would prefer to do it the calculus way just because we've been doing calculus all year. Okay, so now for part B, we want to know where that line is tangent to the curve. At that point, that would be where their derivatives are equal. So you have to use calculus here. So if that line is tangent, you take the derivative of this curve and set it equal to the derivative of the line. So I'm going to get rid of this part. That doesn't do us any good. And what is it? Kx plus 3. So this y prime is equal to k. So basically you need to know where 8x minus 12 equals k. There's it. What's the problem with that?
Hold on.
No.
So we know if they're tangent, their derivatives have to be equal. I did that. But we have a slight issue. Can anybody tell me what that issue is?
There's 2 variables.
There's 2 variables, which means I need...
Where did you get the other?
It's part B now, Deborah. They gave us that.
You need another equation.
I need another equation.
Wait, I have a question.
Yes, Bridget.
Since that line is tangent to the curve, when they intersect, their derivatives will be equal to each other, right?
Yes, and you used a very important word there. So it's not enough for their derivatives to be equal. They also have to intersect. That is where we get our second equation from, which means that the y equals equations must also be equal to each other. So y.
Well, I did the thing you told me I couldn't do on the other one here. So I don't know.
Well, if you did this on the previous problem that you're talking about, you did the derivative part for nothing because it didn't get you anywhere. But this is the work you would have done anyway. So you still did the correct work, which is what I was thinking you did. So at this point, you solve this equation. Again, it's going to be just like we talked about on the previous ones. So you get minus 12x minus kx plus 4 equals 0. And then solve this using the quadratic again. You're not going to be able to factor it. Jesus. So if we use the quadratic on this, you need it as 4x squared minus, let's see, so we're going to do minus 12 plus kx plus 4 equals 0. And then use the quadratic on that, I think. Oh, you can substitute in for k, which would probably be your best option at this point. So I wouldn't do this line. I would substitute in for k right here. So you get 4x squared minus 12x minus 8x minus 12 times x plus 4 equals 0. That'll probably make this a little bit easier, not tremendously, but so 4x squared minus 12x minus 8x squared. What was that? Minus minus, so plus 12x. Ooh, that does make it easier because the x's cancel. Plus 4 equals 0, so by 12x, you get negative 4x squared plus 4x, or plus 4 equals 0. So x is equal to plus or minus 1, and then solve for k, because I believe k is the value we're looking for. So 8 times 1 minus 12 equals k. So negative 4 could equal k, or you get 8 times negative 1. So k equals negative 20. So there's your 2 answers for k. Did I get it correct? I did. Yay. Okay, so there is the first 6 questions. If you have not worked on them or finished them, make sure you work on the next 6 questions. And in case you didn't hear at the beginning of class, I can see how much time you're in ACE Math. So make sure you're doing your work tonight, please. All right. Any questions before we go?
Why'd you use the quadratic from earlier?
What quadratic? You mean why didn't I use the quadratic formula?
No, why'd you plug in? Oh, wait, never mind, I got it.
Yeah, I plugged in the the derivative. It made it a lot easier. It ends up being real super easy. If you wouldn't have done that, it would have been a pretty nasty quadratic, and it wouldn't have been the best thing in the world. So it's possible and doable that way, don't get me wrong, but this is by far the easier way.